Hi, I'm Alex Jackson from NIWC Atlantic Public Affairs. I'm a public affairs specialist here in Charleston, South Carolina. And for Naval Horizons, we're going to be talking with Daniel Smith. Daniel, thanks for joining me today. Can you tell us a little bit about yourself?
Sure. I'm the Radiofrequency Test Facility Lead here at NIWC Atlantic. I graduated with a bachelor's in electrical engineering from the University of Alabama in Huntsville. Prior to that, I studied industrial electronics and music at Northeast Alabama Community College. I do a little bit of everything around here. We'll talk about that later, but I'd love to give a shout out to my team. I do a little bit of everything, but without them, we wouldn't accomplish anything. So,
Thanks, Daniel. Can you tell us a little bit about how you got connected with the Department of Navy?
sure. When I was at the University of Alabama in Huntsville looking to finish up, I read about this DoD Cyber Scholars Program, and the way it worked was it would pay for your college for X amount of years, and then you would have to work for the DoD for X amount of years. And it paid for my college, it paid for my books, it paid for all kinds of things. And then I graduated, and they said, we need you to move to Charleston, South Carolina. And I said, do I have to move to Charleston, South Carolina? And they said, well, you can pay back all the money. And I said, okay, I'll move to Charleston, South Carolina. And that's how I got here.
Well, it's certainly a nice day here in Charleston, so glad you came. I wanted to get to know a little bit more about how you got connected with electrical engineering and how that work affects what you do here with NIWC Atlantic.
Sure. So I've always been interested in process control, automation, programming. They've always been my favorite things. And that's why I decided to go for industrial electronics and electrical engineering. And then I really didn't hear about NIWC at all, ever. I mean, I was so far away. But then the Cyber Scholars Program was like, hey, you're going to be going over here. You're going to be working for them. I said, okay, I'm down for that. You know, Huntsville's got tons of DoD stuff. I just never did anything with NIWC. It was all Redstone Arsenal, missiles, all that kind of thing. But, I mean, so far it's been pretty great. There's lots of different software I can write, process control things I can do. It's going well.
And speaking about your facility, we're here at Poseidon Park where you all work and test these pieces of equipment. Can you tell us a little bit about what the facility has and the type of work that you all do here?
Sure. So we do 2D pattern testing, 3D pattern testing, co-site testing, electromagnetic compatibility testing, rad-has testing, and all those are just fancy words. And what it really boils down to is we are evaluating how well antennas can conform on vehicles, you know, how far away you can communicate to them, if they're good from all directions. And we're ensuring that those systems don't harm each other. So like if I transmit out of this antenna, I want to make sure it doesn't blow up something attached to this other antenna. And we're also ensuring that it's safe for personnel, ordnance, and fuel to be around. Because, you know, you don't want to be in a gunner seat and have some weird electrical system come on behind you and harm you in some way. So we do that testing too.
All right. Is there anything else you'd like to add?
Let's talk about why communications are important. Communications have been a hugely important thing for conflict for centuries and centuries and centuries. You know, communication has always been king. The group with better communication often is the victor in the end. And there's lots of different reasons for that, but our antennas and ensuring that those communications are effective allow coordination from hundreds to thousands of individuals simultaneously so that they can all operate at the same time, start exactly the same way, where they don't run into each other. And it also helps keep our communications secure where adversaries don't pick it up, because you definitely don't want your adversary to know what you're talking about, because then they'll know what you're doing too. You know, a lot of our stuff deals with antennas on trucks. If you're in your car listening to the radio, that's coming out of a radio station somewhere. And what's happening is the radio station is playing music through a computer or a CD player or whatever it is, and it's going to an amplifier and some other signal processing equipment. Then it's coming out of an antenna, it's traveling through the airways to your car's antenna. It's coming through your car's antenna into your car, your radio's doing some signal processing and other stuff to it, and then it comes into your car as music. And a lot of what we do is the same as that. We have a whole bunch of antennas on vehicles. They're just used for different things, but it's the same technology. We're utilizing it for communication and other systems.
And what other examples can you share about how this work impacts you? Why do you enjoy doing it so much?
Okay, so I love process control and automation. When I was at university, I took electromagnetics, didn't like it. Took electromagnetics 2, didn't like that either. I took antenna design and analysis, didn't like that. And now I'm in charge of the Radiofrequency Test Facility for NIWC. And that's okay, because I've always liked software, I've always liked process control, and we still have that here. So when we're doing a test run, I click a button and it sets up a measurement. It takes the measurement, it stores the data in a file, and then it moves something, it takes another measurement, moves something else, it takes another measurement. And it all does this through software. And I get to write a lot of that software, and then I get to write more software that pulls that data out of those files once we save it and does different analysis to it. And I love doing that kind of thing. I love writing software, and I love making things move in new and interesting ways.
And then the way forward, what do you think the next generation of science and technology work is for the Department of Navy and for the federal government as a whole? Where do you see the future going?
So out here at the Radiofrequency Test Facility, we deal with a bunch of antennas, and the way I see antennas going is, we're moving into higher and higher frequency ranges. We've been doing antenna stuff from 2 megahertz up to 6 gigahertz for years and years and years. But now we're seeing a shift to even higher, even faster signals. We're going all the way up to 40 gigahertz at times. And that's something that's been really, really cool to see, because the faster your frequency goes, the smaller your wavelength, the smaller an antenna you can have for an effective antenna. So we've got antennas that are like, 2 inches tall, doing the job of these antennas that were 30 feet tall in the past. And it's just super amazing to see that.
Can you describe on what that means to increase the frequencies and how that impacts what the type of work you do?
Sure. So RF signals are like a sine wave. There's something going back and forth at some speed. And it's using that wave to carry information. It's going to change some part of that wave. If it's changing the amplitude, it's, maybe shifting that wave a little bit bigger, a little bit smaller. If it's changing the frequency, it's shifting the frequency over a little bit this way or a little bit this way to communicate ones and zeros through the airwaves that can be turned into data packets that are read and processed by your computers. It's all ones and zeros, right? Increasing in frequency means that you're just doing that faster. So if I have a 60 hertz signal, that's what all the power in your house and stuff runs on. It means that I'm going back and forth once every second. Or no, I'm wrong. 60 times a second. It means you're going back and forth 60 times a second. And as you increase in frequency, that number keeps going up. If you're at 100 hertz, that means you're cycling 100 times a second. If you're at 1 megahertz, it means you're cycling 1 million times a second. If you're at 40 gigahertz, it means you're cycling 40 billion times a second. It's just how fast that wave is moving to carry data. And the faster your wave goes, the smaller your wavelength gets. So the faster you move, the smaller the wavelength gets, the smaller your antenna can be.
And that is important because you want to make sure that you can communicate faster. You want to be able to transmit data faster. Is that the major purpose for this?
That's part of it, but it's not the main part of it. So it does increase your speed some way, this, that, or the other, but for the most part, for lots of different reasons, your speeds end up being kind of close to the same. What it does do is it allows you to change your hardware around and use very different type of hardware. And also, with more and more systems communicating with each other, there's more and more noise. So if you have 2 people in a room talking, it's kind of noisy. If you have 3 people in a room talking, it's a little bit noisier. If you have 100 people in a room, it's even noisier. So by increasing how much spectrum we're using, we're making the room bigger and bigger and bigger. Maybe we still got a whole bunch of people in the room, but the bigger our room gets, the less it's a problem. If you have 20 people in a 20 square foot room, that's not super pleasant. But if you have 20 people in a gymnasium, it's kind of whatever. And that's a big part of it, is just moving out into making the room bigger.
Over the next 15 to 20 years, where do you think technology will go and how we can help advance our warfighting capabilities?
Wireless communications is huge in industry, it's huge in homes. If you like Wi-Fi, you like wireless technology. That's how it works. And we're moving more towards an Internet of Things approach in homes and businesses where, maybe your refrigerator talks to your coffee pot, talks to your vacuum cleaner, talks to your front door, talks to your phone, and it can have all kinds of different advantages for you. So let's say your refrigerator monitors with what you put in it. It can automatically order stuff for you. That's terrifying to a lot of people, and that's fair. But maybe it's your vacuum cleaner. Maybe you walk out the door and your system sees that your phone's left the area and it goes, you know what, it'd be a great time for me to clean the apartment. And it vacuums, they even make mops now. It vacuums, it mops your floor, it gets everything put away, everything done for you. And then you come home, your apartment's clean. You didn't even do anything. It just happened. It's like magic. And a lot of that is enabled by wireless technology. All these different pieces have to communicate together, and you can run wires, but it's much, much easier to just do all of it through wireless connection.
Daniel, can you tell us a little bit about some experiences you've had within your team that you really enjoyed?
Sure. So we do all kinds of different testing on different systems and trucks, and part of the reason we do that is we have to operate all the systems in a vehicle to see if they interfere with communications or the antennas. So like we'll turn on the truck, we'll turn on the headlights, we'll move stuff around, do all that. And one day we're doing one of those tests, and I look up and I realize that I'm spinning around and driving around this super incredibly expensive, super incredibly cool missile launcher system. And that was a really surreal experience. It's like I'm getting paid to play with a big missile launcher. And it was just a surreal, really cool experience for me.
Yeah, that's a really unique opportunity that most people don't get to have.
Yeah. It didn't have any missiles in it or anything, but we were driving it up and down, spinning it around, doing different stuff just to see how it would impact the antennas, and it was cool.
Can you tell us some advice that you would give to someone who may be interested in STEM?
I would say find something you're passionate about. So, like I just said, I really didn't like antenna theory. I really didn't like different types of electromagnetics work, but I was really, really passionate about software, computer science, and electrical work. So that passion helped me get through all those courses. I knew what I wanted to do in my career. I knew kind of what I was going to go for, but I just had to get through that college degree in order to move on and do those things. And, if it's not something you're passionate about, it's going to be very, very difficult. But if you find something, it's like, I like this. I want to do this. I really enjoy writing software. I really enjoy wiring something. If you find that, then you just have to check off the boxes to get to a career where you're doing that. Maybe some of those courses are incredibly hard. Maybe some of the mathematics is absolutely ridiculous, but you just got to get through that process and then go on and perform the work that you're passionate about. Because if you're passionate about it, you're going to do well at it.
Well, thanks for your work, for what you do for the Department of Navy, and for us here at Naval Horizons. Thank you for your time today.
Sure.
I'm Alex Jackson, signing off.